Okay, round one for you. Round you don't want to know for me. Here we go. Let's try this again. So, rational function is when you have a polynomial that's got like an x, could be linear, so it could be like a 3x plus 1, or it could be quadratic, where it's like 2, I don't know, make up a quadratic, 2x squared plus 5x minus 1. So you've got some x values in the numerator. We've been doing a lot of graphing with reciprocal functions, but those had the number 1 or a different vertical stretch in the numerator. Now we're going to have actual polynomials in the numerator. So one of the first things we have to look for now is something called wholes. All this is one of the things we're going to add to the checklist when we are graphing these graphs. A hole exists when a factor cancels out in the numerator and the denominator. So factor cancels out from numerator and denominator. So when we were looking at this before, we would have said, oh, the denominator happens at x minus 1. So there's a vertical asymptote at x equals 1. But now we're learning that because there's something different in the numerator that might change what's happening. We're going to factor the numerator. This is a difference of squares. Let's make sure we remember that. Diff of squares. So we're going to factor the numerator into x plus 1, x minus 1, all over x minus 1. So this was one of the units we did in grade 11 when you were simplifying rational expressions, and that was all warm up for this. So because there's a factor in the denominator that can cancel out with 1 in the numerator, this actually represents at x equals 1 is actually a whole. It doesn't change anything about your domain. You still say, x can't equal this value, but it does change the graph from being something that looked really crazy to being a linear graph with a hole, literally a hole. You can see it over here. A hole exists at a specific value. So this is what I would expect to see on a test where you say, oh, okay, this is the vertical asymptote. Actually, it's a hole. And you're going through, like, this is me seeing you go through the thinking process because you're eliminating things in the graph or you're kind of like zooming in on what they're actually supposed to be. So for this example over here, we've got the graph of x squared minus 4. Again, another difference of squares. So let's look at that algebra. That would be x plus 2, x minus 2, all over x minus 2, boom, boom, and we're left with the graph of x plus 2. But because this is where the restriction is, x can't be positive 2, and we see that on the graph up here with an open point of discontinuity. Okay, so our domain would be x such that x cannot be 2. X is a set of the real.